Okay, so last but not least, question 19. Figure 17 shows a Geiger-Müller, a GM tube, used for measuring radioactivity. So here is our Geiger-Müller tube, that thing there, connected up to the counter behind it. So it's just that, about the size of a Pritt stick normally, and a little stand there. That's what's measuring this radiation. A radioactive rock is placed near the front of the GM tube. Radioactive count rate is first made in air. The count rate is measured again with 3 of the different absorbers between the rock of the GM tube, the rock and the GM tube, and figure 19 shows the count rate measured. So let's have a look at the data, shall we? Just with air. So we've got a rock, we've got 3 centimeters of air, and we've got a count rate of 1,200. We put a thin bit of paper in. It drops down, what's that? That's a drop to 900, so that's a drop of about 300 it drops by. So it's about a drop of a quarter. We then put some aluminium in, and if we look, it drops by about 600. So it drops by about 2/3 there actually. So this is a drop of about a quarter, from 1,200 to 900. From 900 to 300, that's about a drop of 2/3. And then 2 centimeters of thick lead, we've got a drop of, well, about 300, which is a drop of 9/10, something along those lines. Quite a considerable drop each time. What's the question say, having done all that? A scientist has an idea that the rock emits 3 different types of radiation. Explain how the data in this table explain how the data supports the scientist's ideas. So we need to remember the 3 types of radiation. They are alpha, beta, and gamma. There, alpha, beta, and gamma. Alpha is stopped by air. Beta is stopped by paper. Beta is stopped by aluminium, Al, and gamma is stopped by Pb, lead. So what have we got here? Just air on its own, we've got 1,200. Now, when we put some paper in, it drops by a quarter, it drops by about 300. What does that tell us? Well, gamma and beta are so penetrating that they won't notice the paper's there. They'll just pass straight through the paper. So because it's such a big drop, it's not stopping any alpha and any beta and gamma. It's the alpha that it's stopping. So we can start off by saying that when paper is added, the count rate drops by about 300. Okay, that little squiggly line before the 300 is about 300, which shows that alpha must be being blocked by the paper as beta and gamma penetrate paper. Okay, so because we've got a gap there, it must be the alpha that's being blocked. So we go from paper to aluminium, and we've got a drop down to a drop of 2/3. So we can add a little bit in. So that's our first bullet point. Our second bullet point, we can say when the aluminium is placed, there is I'm going to put significant drop to 328. This must be due to the beta particles being stopped as gamma penetrates the aluminium. And lastly, we've now got lead, and it's dropped again. So we say the lead blocks the vast majority of the radiation, which shows that gamma must be present, as it is the only one that penetrates the paper and the aluminium, but is blocked by the lead. Okay, let's just check we've answered the question. Explain how the data supports the scientist's ideas that there are different types of radiation, because as we go through each one, the count rate drops by a different amount. I think we've done that. My apologies if my handwriting is getting slightly scruffy at the end. I hope that was okay. Thank you.